Hello everyone and welcome to Van Tech Corner. In this video, we are going to install the OpenWRT on the Mikrotik Routerboard RB2011 series. And actually this guy is quite similar to the Mikrotik RB750GR3 which we have done previously. And we're going to use this common procedure to install OpenWRT with Netboot or TFTP server. This is the guide that we are following, and for this router board we have different versions, so make sure you select the correct version, the firmware for your device. Alright, because we have different models, for example with touchscreens or without touchscreens or with the SFP port. Right here, let's check out the Winbox settings, and right here I have the RB2011 UIAS. And first of all, we need to, of course, back up the license of the RouterOS. So let's go to System and then License. And right here, this is my software ID and serial number. So I suggest that you should hide this information from the internet. For my case, I just use this as a demo, and I'm going to use OpenWRT, so I don't mind on these serial numbers or software ID. But still, first of all, we need to click on this export key, and then we need to save the key somewhere else. Alright, so we have saved our license key correctly, and to make sure, I will export it 2 times. Alright, so now we should be ready to go. And first of all, let's go and get our firmware. So for my case, it is RB2011 UIAS. So this is my firmware. And for these routers, of course, we will need the initial RAM disk and then the system upgrade image. Right, so just save the link, download the firmware. And then the system upgrade file. Alright, so now we have our file already. And next, you are going to need the TinyPXE. So this one is a guide for Linux, but if you are not using Linux, you need to use TinyPXE application. So right here, I have my application downloaded. And then let's go and extract the file right here. So inside, let's open the application. But before we do that, let's set a static IP address for our network interfaces. So I'm going to go to my network interfaces right here, right click, open network and internet sharing, change adapter option, and then right click properties, and then go to TCP IPv4. And I'm going to set an IP address of 192.168.1.10 for my interface. In order to set the interface, you need to make sure that a cable is connected between the PC and the router so that you can set it. So we are good, hit OK. And now we lost the connection to Winbox because we have changed to a new IP address. But this is very normal. So now let's open our TinyPXE application right here. Alright, so this is the TinyPXE application, and right here, make sure the option 54 DHCP server is turned on, and everything is set like this. And right here, we also untick the file name and select our initial RAM disk. So it is this one, initial RAM. Alright, hit open. And now what we need to do is turn off our router board and then remove the one cable and plug this cable. This cable is from my PC to the port number 1. So Ether 1 just right here. Alright, so now we can hit the online buttons on the TinyPXE application. And we can see that it is started. Alright, what we need to do is to press and hold the reset buttons right here while powering on the board until we see the activity on TinyPXE application. So let's do that. Alright, so press and hold the reset buttons and powering on the board. Alright, so keep holding the reset button until we see activity happens on the TinyPXE application. Alright. And right here we can see that ether boot on the LCDs of the RB2011. So we can let it go. And then on TinyPXE we can see that we have an activity and it's a read of file OpenWRT. So the OpenWRT firmware is now being transferred to the router and it should be up and running shortly with OpenWRT. So we can see that the Ethernet LED is blinking, and we know that we have activities ongoing with Ethernet number 1. So we have seen another request, and I assume that OpenWRT should be up and running on this router. So I'm going to remove my PC on Ether 1 and connect it to maybe Ether 3. And now we can safely click the apply button. So let's go to Firefox, and right now we should be able to reach the OpenWRT router at 192.168.1.1. And perfect, it is working great. So by default there is no passwords and we can just log in. So here we are, OpenWRT running on the RouterBoard 2011 UIAS. And this is not the end. What we need to do is go to Systems and then Backup and Flash Firmware. And then click Flash Image. Browse. And then go to the System Upgrade. Right, so we need to select the non-large SWAT system upgrade file.bin, hit open and hit upload. Alright, so we don't need to keep the settings, so we just let's go with it. Alright, so we can see that the device is restarting, rebooting, starting kernel. So right now, I think that OpenWRT should be up and running on this RouterBoard 2011. Alright, so let me go to the network interfaces right here. Click Properties and then change it to DHCP and hit OK and then OK. So let's see if we receive the IP address from the DNS servers of the router. Alright, so we have a new network up and running. So right now, OpenWRT has been permanently flashed to our RouterBoard 2011. So let's log in. And yes, everything is working as expected. So we can see that the LED is still showing up Mikrotik and then starting kernel and no more update from that, but it's fine. So we will back to LuCI to proceed with the configuration. And yes, so now you should be able to connect your WAN cable to Ethernet port number 1 in order to have a working internet connection. Alright, so as usual, the very first thing I'm going to do is go to System, Systems, and set the host name, and then change the time zone. So after this, let's see if we can still access the router. So I think we better go to 192.168.1.1 and log back in. Alright, so next let's go to Systems and then Administrations and set a new root password. Let's go to Network Interfaces. For this Routerboard 2011, we are still running OpenWRT 19. That's why we still have the switch page. So the configuration should be easier, and as you can see, we have two switch 0s and switch 1. So switch 0s is port Ether 1 to 5 and including the XFP port, and switch 1 is our 100 megabit switch port. Alright, so let's go back to network interfaces, and right now Ether 1 will configure at our 1 port. First of all, let me establish the added edge connection to the routers, and we're going to have a quick speed test. Root and the password. So the first things, obkg update. Obkg install htop. Alright, so now we have htop running on the RB2011, and let me do a quick speed test. Let's start the test with a quick speed test, and I'm using a 200 Mbps internet plan, so I expect the speed should be more or less at around 240 or 230 Mbps. That's a good speed. And next, let's try with the iperf test to a server in the one side. Unable to connect to the server, so looks like I need to restart the iperf test. Alright, let's give another try. With default firewall configurations with no offloading, we have 270 megabit per second throughput with the one interface in DHCP client. And let's give it another try to confirm that we have the correct result. Alright, so more or less 267, so it is very close to 270. So let's give a try with the OpenSpeedTest. Alright, here it is, and let's go. Alright, so with OpenSpeedTest we have 250 Mbps for download and 249 Mbps for upload. So now let's go and enable software offloading and let's see if there are any differences. Software flow offloading and save and apply. Alright, so let's run the test 255 and 250. Refresh, start. So with software offloading, we have 650 Mbps download with OpenWRT, and we can see that the CPU is fully utilized. And then we have more or less the same upload speed with OpenSpeedTest, which is 700 Mbps. Alright, so how about iperf 3 test? So let's give it a try. Alright, so we have 600 megabit per second iperf throughput with OpenWRT. So let's give a try and enable hardware offloading and let's see if there are any differences. Let's go. We can see that there are not much changes for hardware offloading, and it looks like that hardware offloading is not supported on this router because we are still having the same result, and we can even see that the speed is fluctuates, which means it's not a stable result. And let's run a test with iperf. So we can see that there are not much changes when we turn on or off hardware offloading. So I assume that hardware offloading on this router is not fully working. So after we have performed some tests with the WAN interface at DHCP client, let's configure PPPoE with VLAN and let's check out the device performance. For this device, we do have the switch menu. So by right, you should be able to go to this switch page to configure VLAN, and usually you are going to create a new VLAN, and let's say the PPU service is running on VLAN 35, you are going to set a port 35 right here. The CPU port status is tag and the WAN port is tag, and right here it is off, right? And after that you are going to create the interface with the new VLAN. But for this branch, for this RB2011, we have a problem, and if you are going to configure VLAN with LuCI, there will be some bug and the interface will not be up and running, and this is the problem that I have. Alright, so I have tried a few times, and in order to configure PPPoE with VLAN, we will need to do it with the command line. Alright, so let's just reverse the change, revert it to the default configurations, and for now we are just going to create the PPPoE connection with LuCI, and after that we are going to assign the VLAN with command line. So edit go to General Settings, change the protocol to PPPoE, click Switch Protocols. And right now we should be able to fill up our username and password. Alright, so this is it. And by right, if you want to change something, we can change it later. So that's all for the username and passwords. Leave it at default. Leave it at default because we're going to do with CMD, and leave it at 1 firewall zone. So we all set, hit save, and then save and apply. Alright, so right now we have no internet connection, and I believe that the PPPoE connection is not successful. So let's go back to our terminal right here. I'm using PuTTY, and let's edit the network configuration file. Alright, so press the down arrow key to go down to the switch config page right here, and press the I key to switch to the insert mode. So right now you can see that the key changed to I. Alright, so the first one is VLAN ID number 1. This is for our LAN switch. And then the VLAN ID number 2 is for our one port, which is Ethernet 0 or the port number 1 on our router. So in this case, we want to change it to 35, and then the status will be tagged. So it will be 1T and 0T. So 0 stands for the CPU port, and the CPU port should always be tagged. Alright, and then we will need to go up to our PPPoE connections and change the VLAN to Ethernet 0.35. Alright, so the option interface name, it should be Ethernet 0.35. Okay, and make sure you specify the correct username and password. Alright, so once we make sure everything is properly configured, let's press the EXE keys on the keyboard and then colon, right and click to save the change. And after that, let's run service network restart. And right now the internet connection is still down, but it should be up and running shortly. So let's be patient. Alright, so it turned back to online. Okay, so right here we do have the IPv4 and IPv6. So I believe the internet connection should be up and running. Alright, so let's do a quick speed test and let's check out the CPU usage. And for your information, right now we are using the default firewall configurations and there is no shortware offloading enabled. Let's go. I'm using 200 Mbps internet plan, so by right the speed should be around 220, but we can see there a little bit of delay and there a little bit of throttle, but let's check it out. So let's change to another server, maybe Viettel, and let's go. Alright, so it looks like the limits for this CPU is around 200 Mbps PPPoE connection with VLAN. Let me run the test to another server. Select automatically. No, I want another server. So let's give a try with the last server before we are moving on. Alright, so it is 200 and around 205 Mbps. and on upload side we have 200, and alright, so it's around 200 Mbps with 100% CPU uses. Alright, so that's a good result. Now let's give a try with shortwave offloading and see how the router is doing. So go to firewall and then shortwave offloading and save and apply. So some people saying that shortwave offloading doesn't work with PPPoE and VLAN, but let's give it a try and let's see if it is true. So right now we are 205 and let's run with the same server. Alright, so we do have the same speed because we are using the same internet plans, but this time we can see that the CPU is only around 50% uses. That's a lot of improvement. And the same for upload, we can see that the CPU uses only 53. Alright, so I want to run another time before we make the conclusions. So, yep, 200 Mbps with 50% CPU uses. That's not bad. And we can see that for this Routerboard 2011, the latest OpenWRT version is still 19.07 and it is based on AR71XX. So this branch audit tree is deprecated and it had been converting to the new branch, which is ATS79. And for this router, there is an open pull request to add support for Mikrotik Routerboard 2011 to ATS79, and it is still ongoing. So I hope that one day the device will be merged into OpenWRT matter very soon. But right now we can see it is still ongoing and there is something to be done in order to make it happen. So thanks to the team for all of your hard work, and we will be checking out this pull request for further details. And right now we have a working internet connection with the RB2011, and one bad thing about the small LCD screen is that we can't control it or we can't turn it off, which is a downside. So if you have any idea how to turn it off or how to control it to show some statistics, please let me know in the comment. So that's all for this video. Thanks for watching and see you all in the next video.